Hello, myself Anuja Jadhav. Today I am going to give presentation on a research paper accepted as ICMISC. Our paper number is 214. Our paper title is Plant Quality Assessment and Disease Detection System using Artificial Intelligence. Following are our authors. So, problem statement. Agriculture is the most important sector and backbone of Indian economy. Plant disease detection is crucial problem. If we address and tackle the problem, then it will definitely play instrumental role in the lives of farmers. Thus, adapting automated system by utilizing artificial intelligence, machine learning and deep learning can provide us with effective solution in long run. Also, manual diagnostic of plant illness is very difficult and tedious task. As the technology is growing at a super fast rate and availability of so much infrastructure, we can definitely increase the agricultural productivity and sustainability. So it is very much noteworthy to initiate an effective approach that will provide effective solution, effectiveness and methodology. Purpose. The purpose of our paper entirely lies in helping and aiding farmers by focusing on computation and automation techniques in agriculture and by deploying various distinct effective models falling in the category of artificial intelligence. We also aim for increasing productivity, life cycle, efficiency and economic growth. As we can see, plant disease outbreaks are very constant and they are increasing at a very rampant rate across the globe. So measuring the disease incidence, its severity, consequences and quality is very much significant. Also, we can have great tools, technologies these days to aid and address the quality and disease of crops. The motivation completely lies in advancement in agriculture and farming with preliminary knowledge on plant health. Secondly, addressing the scarcity and security problem. Lastly, execution of an effective artificial intelligence and machine learning model promoting productivity and shape agricultural infrastructure on global scale. Also, precision agriculture is one of the trending topic and therefore the great motivation also lies in the same. The main objectives are distinction between traditional methods by studying them with respect to the deep learning model deployment. Also to plot the training and validation accuracy curve to increase the accuracy and recognition rate of our trained models, to deploy effective algorithms, flowcharts and techniques to assess the quality of plants and diagnose the diseases, to perform overall analysis on the model. This slide comprises of literature review from few of our referred papers. First is Poonam Bedi and Pushkar Gole, who have written the paper Plant Disease Detection using Hybrid Model based on Convolution, Autoencoder and Neural Network. So it was published in the year 2021. This paper concentrates on plant diseases in their growing phases and also gives us a very new and distinct hybrid model based on the concepts of CNN and CAN. Second is application of artificial intelligence in detection of diseases in plants. Published in the year 2021. This paper aims to detect diseases in plants using AI. Also, it describes the different sectors of AI in agriculture like image-based insights, computer vision, robotics, IoT, etc. Machine learning for plant disease detection by Aliyu Abdu and Musa Mogji and Sheikh. So this paper was published in the year 2020 and which provides a comparative study and analysis by model implementation of two very popular methodologies of ML and deep learning. using the plant leaves image dataset. Next is the maize leaf disease detection and classification using machine learning. Also focuses on many of the traditional classification models like SVM, KNN, decision tree, random forest. Next is a survey on detection and classification on cotton leaf diseases. This paper basically describes and categorizes cotton plant leaf diseases using ML. The assessment on background elimination and segmentation method is done and deployed. Next is the flow chart of our proposed methodology. So our paper methodology fixes around the central idea of plant disease detection using CNN architecture. So the CNN architecture exploited, it comprises of first the input layer, and next there is a convolutional layer with active function, pooling layer, then a fully connected layer with active function, and lastly the output layer. The flowchart comprises of a concept of acquiring the image dataset using a mobile device. In a paper, we have the primary mode of data collection is GitHub, from which we have taken the public plant village dataset, followed by data inspection, which comprises of inspection of the sample images, then image processing, which is very much necessary. The objective is pre-processing to strengthen the image attributes and prevent any kind of further image related complications which can impact the quality and input of the images. Next is image augmentation, which is an efficient technique that produces additional random training data from preceding training samples. It enhances the robustness of the model. The feature extraction feature is something which is a procedure for the raw image dataset, which are lessened and divided into feasible categories. Then comes the model training, which comprises of a very commonly used method of dividing the dataset into 80% of data for training part and 20% for the testing part. All in all, the end-to-end model training is done by training data acquisition, updating the parameters, calculating cost function, and iterating the process till the requirements are met. Now the diagnosis of the model is done and the data is further sent to a cloud computing platform, which is further utilized for data storage and real-time interaction and analysis. Next is dataset. So our dataset comprises of here are some of the sample data images which are taken from various diseased plant leaves of pepper, potato and tomato. So there were in total 15 directories and 21 6K files. On the rightmost side we have the graph representing the type of leaves diseases on x-axis to the number of samples of these leaves on y-axis. So in our initial iteration, we have taken in consideration the epoch value which was equal to 10, followed by the initial learning rate to be 1e minus 3, which is a relatively smaller learning rate for the model to converge rather than diverging, as it is significant hyperparameter which determines the movement of minima. The batch size we took in consideration was 64, denoting that from the training dataset, 64 sample images are obtained and utilized to estimate the direction and magnitude of the model before updating the model weights. After tuning the model with above parameters, as given in the figure, the results were obtained. In the next iteration, the epoch value was considered to be 50 with the learning rate of 1e minus 3 and the batch size to be 32. So the techniques like image augmentation, addition of hidden layers to optimize the performance along with Adam optimizer was used, and we can see a significant rise in validation accuracy which was much needed in this following iteration. So lastly, our last iteration comprises of a scenario in which we have considered the epoch value of 50, again changing the batch size to 64. So it was observed that greater the value of batch size, the gradients are vulnerable to less meaningless information, that is less noise. So resulting in finer estimation of gradients. So this permits the model to achieve better minima. Also, the high computation power was used, which resulted in a greater performance by the model, which was like 98.5% of training accuracy with the training loss equivalent to 0%. So to conclude, the fine tuning was done using each and every parameter. The objective of the paper was to execute the CNN to validate and train the model, and it was thus accomplished. So our further scope was using the CNN state-of-art deep learning classifiers and working on the various phases in disease detection. So thus we have accomplished a significant and effective model with optimal results by deploying the artificial intelligence technique in case of farming. These are the references we used. Thank you.